right, we're going to rationalize the denominator, but this time we're going to have cubed roots. Okay, so you do not do this the way it would be done if it was a square root. If it was a square root, you multiply by the denominator over the denominator, and that makes a perfect square. But with the cube roots, you have to create a perfect cube. Okay, so the cube root of 9 is not in my list here. So I've got to make one. I've got to manipulate the problem so that it creates one. So 9 goes into 27. I look over here and I find something 9 goes into, and I see it goes into 27. So if I can make this denominator here a 27, the cube root of 27, I can get rid of that radical there. So the way I do that is 9 times 3 is 27. So I'm going to multiply by the cube root of 3 over the cube root of 3, which is still just the value of 1. So I'm multiplying this by the value of 1, and I don't change its value any. All right, so when doing so, my numerators will become 2, the cube root of 3, and the denominator will become the cube root of 9 times 3, which is 27. Well, he is the perfect cube, and we know that the cube root of 27 is 3. So the denominator becomes a 3, and the numerator cannot be simplified. So let's do this again. We have 5 over the cube root of 32. I know I'm looking at my cube root list, and 32 is not in it. So I'm trying to think, well, what will 32 go into in this list so I can use it? And 32 times 2 is 64, so I can create the 64. I will multiply by the cube root of 2 over the cube root of 2, because 32 times 2 is 64. When I do so, I have 5 cube root of 2 in the numerator's position, and the cube root of 32 times 2, which is 64, in the denominator's position. So the numerator will not simplify, so that's 5 cube root of 2, and then the cube root of 64, of course, is 4. There's nothing else to do to that problem. Sometimes you just have variables down here, and you're still doing the same thing. You got to create a perfect cube. So I know that I would have to have 3 x's to be able to pull the x out from under the radical. So I will multiply by the cube root of x over the cube root of x. And that creates 2 cube root of x in the numerator, and the cube root of 2 x's plus 1 more x would be x cubed. And you see the cube cancels out the cube root, and the x is freed from the radical. 2 cube root of x over x.